Okay, so today we are going to discuss about the buckling analysis of connecting rod. Okay, so we already know what is that buckling. Basically, it is due to that stresses, it's going to bend. Okay, so here you can see in that connecting rod, we are going to give that pressure of 40 mm at this place, and obviously at that connecting rod that basically is connected to crankshaft, it's going to be fixed from here. So we are going to fix our component from this side. Okay, so after that, what we need to do is we need to go to Ansys and we are going to run this problem, and in that basically what we are going to do, we are going to run two things. One is static structural and another one is going to be your eigen value buckling. Okay, so what we need to do is we need to just we have a model already created over here, so I'll pick it from here. Okay, so I have saved it somewhere, so just give me a second. Yeah, this is that model. Just I'll copy this model from my pen drive, and you can make this model, but yeah, it's a very complex component, so it's going to take a lot of time. Okay, so we will just go here, and first we are going to take that static structural. After that we are going to take the eigenvalue. You are just going to drag it, and up to geometry you need to align it. So just click here and align up to geometry. So first of all we will need that geometry, so right click over here and you can import your geometry. Okay, so I'll import my geometry, I'll browse, and obviously it is on that desktop. Okay, so it is basically that connecting rod, so just click on this and after that open. So the geometry is open now. Now directly I'll reach to the mesh part. Just give me a second. So I'll just import that geometry and just double click on that model analysis. So that mechanical window is going to open where we are going to run our static structural issue. So here we can see what was that problem given over here, that statement. We need to give this surface as 40 megapascal and this is going to be our fixed support. So just minimize it and click on this. You can see this model over here. Okay, just give me a second. Okay, just give me 1 minute. So now I need to change my voice settings. Actually I need to go for that sound settings. Okay, so now what we need to do in that problem statement, what we have seen, these two things we have to do in that static structure. Pressure we are going to assign. So in that static structure we are going to click. Before that we are going to do meshing. Just generate that mesh. So this is, see, I have given that natural mesh according to that geometry complexity, no, that mesh is going to be according to it. अपने हिसाब से जहाँ पे भी कॉम्प्लेक्स शेप्स या एजेस या रेडियस होगा, इट विल टेक डेंसिटी इज ऑफ मैश इज गोइंग टू इंक्रीज. तो उसके बाद मुझे स्टैटिक स्ट्रक्चर पे जाना है. स्टैटिक स्ट्रक्चर पे जाने के बाद व्हाट वी आर गोइंग टू डू, वी आर गोइंग टू टेक फर्स्ट ऑफ ऑल द सपोर्ट, और यू कैन गिव अ pressure. Okay, first one is going to be my pressure, so I'll check my pressure. What was that pressure over here? That is 40 megapascal. Okay, so first of all you need to just rotate that component. Just select this surface, press Ctrl and select that another surface also. Here we need to assign our pressure. So first of all you need to select that surface. Two faces have been selected. Now we have to give the 40 megapascal load over here. Just you are going to click, you can see here. Okay, the direction is also absolutely okay. It's going to be on that surfaces. So now we need to give the fixed support. Okay, so we need to click that fixed support and need to select the crankshaft side. Okay, that is your connecting rod where it is going to connect with the crankshaft. Okay, hold the crankshaft. So just apply. So this is my fixed support I have given. So that pressure and the both things I have given. Now what I need to do is, we need to basically found the total deformation in the component. Okay, we need to find out the total deformation. Now what we need to go for is, like, we need to minimize this, and we need to have this model already we have generated. Okay, so if you are going to double click again on this model, it's going to open a separate model over here. You would have dragged it like, no, static structure, that model is going to be like, it's going to show both the simulations, the buckling also and structural also. So let's see. So it is only showing that eigenvalue. Okay, so I don't want to do it separately, I want to have it on the both sides. So you can close, because I have not done anything in this. So just remove this, and again I am going to drag this and bring it up to the model. Okay, so right now directly I can reach to the setup. Okay, now you will able to see that static structural and eigenvalue, both results are going to be at same platform. Okay, so my eigenvalue problem is going to here. So what we need to do, we need to define the pre-stress first. Okay, what type of stress you are applying? Obviously it is your structure. Okay, it's your static structural pre-stresses. After that, what we need to do, we need to go for that analysis setting. Okay, these are your maximum mode shapes. Again you can create those maximum mode shapes like 6, and you need to go for the solution. You can solve your problem. Similar mode shapes you are going to get over here. So after clicking here, you are going to get different 6 mode shapes due to that pressure. So it is evaluating those results. You can see here, these are basically your load multipliers. Okay, and it's negative also, and it's maximum 96 in that positive also. Okay, so what we need to do is right click over here, select all, right click, create all mode shapes, and then you need to click the evaluate result over here. Now if you are going to click on that, these are going to be your different mode shapes at that buckling conditions. Okay, so the component is going to buckle like this after applying this load. Okay, these are various different shapes maximum which can be up here. Okay, this is the banding one. Now if you want to check that deformation, you can check the deformation also. You can just check out, because that forces are applied, that pressure is on this side, and here obviously that fixed support is there. So maximum you are going to see, it is going to be a cool area where that minimum stresses are going to be there. But यहाँ पे अगर हम लोग देखते हैं तो maximum pressures are going to be there. So you can just check out that it's expanding a lot. Okay, it should not expand like that. So if we are going to check the deformations and total deformation, these are going to be the different deformations at different mode shapes.